Okay, I think we can start now. So let me stop sharing the QR code. Okay. Okay, so as you notice, I think last night, I don't know, maybe last night, right? I written the your papers, your test papers, question number 3. So you have all the 3 question papers written to you, and you should know your total score now. Okay, I believe the highest score was 77 out of 100, and the lowest is I think it's 3. I don't remember, but okay, this gives you an idea lah. So the whole idea of me giving you this return all the papers, the score, and all the statistics is just to let you know. Yeah, you might think this class is hard, but you can see that some other students are doing very well in the class. So that's something. It is an indication. It is an indication that maybe you should work harder. Okay, because our capabilities are different. So this is just basically, hopefully, an eye opener to you. Some students say the class is hard, but some other students say it is easy, and that is why he or she got a 77, for example. Okay, I'll also attach the statistics for all other classes, all other classes, so you know that which class is better than our class. In some question, we are better. In the other question, we might not be the best class. Okay, and unfortunately, question number 2 has no statistics at all, because I gave the lecturer to fill in the Excel form, and he did his own Excel. So his Excel is very basic, no statistics. Actually, my Excel sheet is pre-programmed. You just fill in, everything will be done automatically. But unfortunately, that lecturer is not doing that. Okay, so it doesn't matter, but at least you know what is question 1 and question 3 statistics. Okay, so any question about the test? Any question about the test grading and marking? Okay, if there's no question, what I'll do is, okay, so it's time for you. It's time for you to decide. Either you want to continue with my class or you want to drop the class. This is very important. This is very important. But my recommendation is always that, because some of you have not done any assignment, didn't come to the meeting. I mean, didn't attend the live video session. Okay, and some of you even, I think, log into the e-learning account very, very rarely, which is very unfortunate. And there's one student who is not even in our Telegram group, our class Telegram group. I was wondering, who is this student? I look at this name and I'm not familiar with the name. And when I check my IMSWeb, oh, this is a registered student, but he did not join our class Telegram. So I don't know how he get all the info. Maybe he asked his friend who is registered, who is in the Telegram group. I don't know. And his attendance is very bad. His attendance is very bad. Okay, so please decide. I think you have until May, I don't remember, maybe May 17, if I'm not mistaken, to drop the class. If you need to drop the class, so please do it before, I think, May 17. You might want to double check this information with the academic office. All right, so let's continue with where we left off yesterday. Before that, not yesterday, a few days ago. Before that, let me share to you our e-learning portal. Our e-learning portal. I think we are way behind. We are way behind. So look at this. Okay, so we are now should be doing this numerical integration. Numerical integration. but I think we are still here. I'm trying to cover this actually. I'm trying to cover this. Okay, I'm trying to cover this. Hopefully you have watched the videos. Okay, and again, this is not my video. This is from Dr. Xiao. Dr. Xiao is not teaching this semester, but he gave me, I asked him to share this video, and he says that's fine. So all these are his material, and the numerical differentiation, if I'm not mistaken, this is my video. This is my video. Okay, and then we have mid-semester break, and this is the week. This is the week, and unfortunately, this is the last day of this week, which is today is the 12th, which is a Thursday, which is the last day of the week. Okay, so what I'll do next after this class is I'll give you an assignment, an assignment that combine everything, that combine curve fitting, numerical differentiation, and numerical integration in one assignment. So basically, I'll be using past year test papers, because past year test paper, the question on numerical integration, numerical differentiation, and curve fitting is in one question. It's in one question. Okay, so I'll be using that as the assignment, so that you can see the level of difficulty of our test. Okay, so if there's no question, hopefully my voice is still okay. Hopefully my mic is better. By the way, I don't like this mic because this mic is far away from my mouth. This mic is on my camera, which is I think about 1 meter from me. About 1 meter from me. So this is the camera, and this is where the mic is. All right, so let's do this. Let's start. Let's continue with our. Let's continue with our lecture. Okay. Okay, so let's share my. Okay, this one. Okay, so this is where we left off last time. I think on Sunday. So we were saying that the idea of linear regression or regression is that we want to minimize the error. Minimize the error. And now in this case, we are trying to minimize the error with respect to our variables. In this case, our parameter A0 and A1. So what we have here is, so this is the differentiation, the sum of residual square. We differentiate it with respect to A0 and set it equal to 0 because this is where the minimum or the maximum is. Okay, but in our case, we know it's going to be a minimum. So this is where we, this is why we integrate, we differentiate. And the same thing for A1. So we set it equal to 0. And then what we have after that is we get this system of linear equation, and we are trying to solve this for A0 and A1. So we need to find what value of A0 and what value of A1 that will minimize our error. So there are a lot of ways to do this. I think for 2 by 2, the simplest way is to do by Cramer's rule. I think you learned this during your high school. Or simply you can just, you can also use what we call elimination. Doesn't matter. Or simply use your calculator. But let me show you this method. Cramer's rule. Cramer's rule is straightforward. For 2 by 2 is easy, but 3 by 3 is going to be a little bit pain in your neck, because 3 by 3 determinant or inverse is not straightforward. It's not straightforward. So what we have here, so what we can do here, let me show you the first method. We use Cramer's rule. Cramer's rule, solve by using Cramer's rule. And it's going to be, for Cramer's rule, we can find A0 simply by finding the determinant of this. For A0, since A0 is with respect to first column here, so what we want to do is to take this is and then summation of xi, summation of xi square. So determinant of this divided by determinant of the coefficient matrix. Okay, n equal to summation of xi over e xi, summation of xi, summation of xi square. So this is the formula, and we can simplify this as this times this minus this times this over this determinant. So the determinant for the top part is just summation of xi square, summation of yi minus summation of xi times summation of xi yi over n and summation of xi minus summation of xi square. Okay, and if you look at your textbook, the answer is slightly different. Okay, but if you plug in all the numbers, you should come to the same answers. Okay, so now we can do for the same one for A1. So A1 is again, so we know that the bottom part is still the same, no change, but the top part will be different. The top part will be something that look like this, because we are going to replace this second column with this. Okay, so this is just n summation of xi times e summation of yi over summation of xi yi, and this will be n summation of xi yi. Okay, minus summation of xi, summation of yi over n xi minus summation of xi square. Right, so this is Cramer's rule. Easy. Okay, easy. So now we get the answer for A0 and A1. So basically, this is just your SLE. You can solve it using the method that we learned before, but I think I did not cover Cramer's rule in our SLE. Cramer's rule 2 by 2 is okay. But when it comes 3 by 3, the problem is that you are trying to find this. It will be, you try to find the determinant of a 3 by 3 matrix is going to be time consuming. So that is why I say, okay, 2 by 2 is still fine, but 3 by 3, I wouldn't choose Cramer's rule. Okay, and then you have to do determinant for this, the top part and the bottom part, the numerator and the denominator. Okay, so that is one way. Or let's look at the first equation. Let's look at A0 here. Let's look at A0. Let's see the first equation here. So let me rewrite the first equation. We know that this is just n A0 plus summation AI, summation of A1, summation of A1, summation of xi equal to summation of yi equal to summation of yi. So can we solve for A0? So if you do this, you know that if you do just a simple algebra, A0 is simply summation of yi minus summation of, oh sorry, before that let me put n here. Okay, A1 summation of xi. So A0 is just summation of A1 over n, or if we simplify this, this is just 1 over n summation of yi minus A1 times 1 over n summation of xi. So what is this? What is this? Anybody? And what is this? Remember your statistics class? So this is just the average of y minus a1 times the average of x. Okay, so this is a naught. So there are two ways to get a naught. So either this one or this one. Okay, so this is the answer in your textbook. This is the answer in your textbook. Okay, this is the answer in the textbook, but I showed you how we get it. Showed you how to get it. Right, so now let's look at an example here. Let's look at an example. So let me share my Excel sheet here. Where is my Excel? So, okay, let's share my Excel. Okay, so let's do this one first, linear regression. Note, this is the point here. This is the point that we have here. So take note that this is from your textbook. This is from your textbook. I just get some of the values. And now, how can we solve this? Note that we know that our relation is f equal to kx. So let's say this is your x-axis is your displacement, and your y-axis is your f. For example, let's do this. And this is your x, and this is your f. And note, we know that k is supposed to be a straight line, right? K is supposed to be a straight line. But unfortunately, when we did the experiment, these are the point that we get. These are the point that we get. So it is kind of not a straight line. So I think you know that this is due to errors. Due to errors. So we know that it might be something like this. There's a point here. There's a point here. A point here. Point here. Here. And here somewhere. Okay, so it's not a straight line. So what we have to do is to minimize the error, and that is why we have all this summation and sum of residual squared. So the whole idea is to minimize. Okay, minimize. So now, if you want to find a naught, what you can do is you find, for example, in this case, a naught is just the average of y, okay, minus a1 times the average of x. Okay, if you can do this, this is just for Excel. So this is the average of this. Okay, we can just copy this. Okay, so this is one way of doing this, but in this case, we do not find what is our a, because we still need our a1. So what is our a1 here? A1 is this one. This one. So you need to do all this math first. So let's do this. So what I'll do here is let me move this. So what we have to do is to find what is n. N is number of sample is 7, right? And is equal to, so let's count how many sample do we have. So we have 7 sample. Okay, 7 sample. Okay, let's move this. Okay, so n, this is n. N is 7. No, I think I better put this somewhere else. I better put this somewhere else because we need to use the table. Okay, so this is the average of x and the average of y. Okay, so what we need is summation of x. Summation of x. So we know this is the summation of x equal to sum of x Okay, this is summation of x. We also need summation of y. Sorry, summation of y, summation of x, summation of y. Okay, in this case, we need summation of x here, this one, and summation of y. So summation of y is just, let's copy this. So summation of x, summation of y, and then we have summation of x times y, x times y. So this is x times y. So this is just equal this times this, which is this. And of course, we need the summation of x times y. Okay, so this done, n is done, and we need xi square. So we need x square here. So this is x square, which is just equal to this square. Okay, so drag this and this 140. 140. What else do we need? So okay, x ada, x square ada, x ada, y ada, xi. Okay, so I think we are done, right? So we are done. So a1 is basically just equal to n times summation of xy minus summation of x times summation of y. Okay, let me, okay, now I need to put this in bracket because this is the numerator divided by the denominator, which is, again, bracket n times summation of x, this one, minus summation of x squared, this one. So this is our A1, A1. Okay, so A0 is equal to this one, summation of the average of y minus, so the average of y, this one, minus A1, what is this? E13. E13 times average of x. So something is not right here. Why? Is this correct? Do you think this is correct? I don't have my solution with me here, but I don't think this is correct. Do you have any idea? What is A1? What is A1? So our equation, our function is y equal to A0 plus A1 x, right? Where A1 is our slope, and our slope is positive, okay, which is okay. But our A0 is minus 8. Oh, minus 8. I don't think this is correct. So let's double check. P14 is the average of y minus A1. A1 is this times A14 is our average of x. Okay, so I'm not sure if I get this thing right, but if I have a feeling this is not correct. So let's double check our A1. A1 is, sorry, A0, sorry, A1. A1 is this, N times C B30, okay, N times C9, which is summation of x times y minus minus A9 summation of X times summation of Y. Okay, divide by N times X, N times summation of X minus, no, this is wrong, This is wrong. This is wrong. So I should have not D9, but this one squared. Okay, summation of X squared. Summation of X, then we squared, not the summation of X squared. Different, Different. So now let's double check that one. Okay. Now this is even weird because I have a negative number. I don't think this is correct. Summation A1, A0. Okay, I think something is wrong with my formula. Something is wrong. Let me check my textbook. I think this should be correct. Summation of N, Xi, Yi, minus summation of X, summation of Y. I think this is the top one is correct. B13N times N times C9. Okay, minus A9 times B9. Divide by B13. B13 is N times Xi square. This one. This is wrong, Not A9, but this should be this. My PC is not responding, okay. D9. This is times D9. Okay, X square. This one is summation of X that is being squared. So this one, okay, this screw up everything. I'm sorry. Let's take a step back again. C9, B13 times C9, which is this one, Xi, Yi, minus A9, A9 times B9. Okay, divide by B13. B13 is this one. Okay, and Xi, which is 9. Okay, B13 is N times summation of Xi, which is this, minus A9 square. Okay, I think I wasted a lot of time here, but never mind. Never mind. If you do this correctly, you should get the answer. But I have another better way to do this. Which is just using Excel. Okay. And by the way, if you do this correctly, you should get the same answer. You should get the same answer. So because we are running out of time, so never mind, let's do this. So what I'll do here is, we know that it is going to be a straight line, right? Because the physical law says that F equal to Kx, okay? And F equal to Kx is a linear line. So you cannot connect this dot to this dot to this dot to this dot and so on. So let's say I change the series type to this. Is this the correct rule? No. K is a constant, right? k is a constant. But if you look at this, k is a constant from 1 to 2, a constant from 2 to 3, which is wrong. So this is not the correct representation of the physical law for spring. So we know that it is going to be a straight line, but when we did the experiment, what we get is this. So we need to do a regression because we know during experiment we might make some errors. So let's do this. I think you should learn this during your technique uji kaji. So at a trend line here, so we know that we are going to take a linear regression, and let's say what we want to do is to display the equation on the chart, and we need to see the intercept. So this is 0.0714. 0.7014. So let's do this. So we go backward by 1 period. And okay, so let's do this. Okay, so look at this. What happened is that we already have the equation. This is our A0 and this is our A1. This is our A0 and this is our A1. So if you do this correctly, if you do this calculation correctly using the formula that I have here, we should get A0 and A1 correctly, but somehow I screw up during my calculation here. So never mind, we can show it later when we have time. So you can see that the slope is 0.83, which is this one, and the intercept is 0.07 here. Right, so this is one way. So how do we know there's error? So what is this fitting good or not good? So let's look at another option that we have in Excel, is that to show the R square. So look at this, R square represent R square of equal to 1 means there's no error. There's no error, There's no error at all. In this case, you can see there is an error here from this point to this point. There's error from this point to this point. There's error. So we have a lot of errors here. The bigger the number, the closer to 1, the better is our error is less. For example, if we are using ruler for our experiment, we might get 86% R square. But when we use maybe calipers or micrometers, the error will be reduced because of the precision That's why when we do experiment, we want to have the most precision that we can have. So this is one way of doing the regression. So I'm still not satisfied because this is not coming to the same value as as this one. But I think you can try it on your own. Let's see. Saya masih tak puas hati lah. Never mind lah. And okay, if you use your calculator or maybe you can check this one. And C9 x C9 times P9 divided by N times A9 minus A9 square. So I'm still not satisfied with this. Maybe okay. Never mind. So maybe I can show you later in next video. But this is one way of doing the regression. Okay, now we know that the function is f equal to kx, and now we know that we have errors. We have errors. So in our experiment, we know that it is f equal to kx, and from our experiment, what we have is plus some error. So our error here. So in this case, what we have is our f. From our experiment, our f is k 0.8393x plus error of 0.0714. So So from our experiment, what we get, our spring constant is this value here, this value. Okay, that is the value. So this is how you do it. This is how you do it. Okay, now let's look at, this is a very straightforward problem because you can see that this is linear. What if we have this kind of problem? Okay, what if we have this kind of problem? Okay, let's look at this one. Let's say we have y equal to alpha x to the power of beta. So this is the, let's say this is the physical law. This is the physical law. So can we do a linear regression here? First of all, is this a linear equation? Okay, we know that alpha and beta are our constants. Our constants are constant. So our alpha and beta are our constants. So our y depends on x. Okay, depends on x. So this is not at all a linear equation. So how can we do this? How we can solve this? Okay, so to use linear regression, okay, the name said linear regression means we need to have a linear equation. Okay, what if we don't have a linear equation for such, in this case, such as in this case? So in this case, it is not a linear equation. And because it is not a linear equation, definitely we cannot use linear regression. So what do we need to do? We need to find a way in such a way that the equation will be linear. So what we need to do is to what we call linearize the equation. So how do we linearize the equation here? Okay, so the equation of a straight line or a linear line is y equal to mx plus c, or in our case, y equal to a0 plus a1 x. Okay, a0 plus a1 x. So how do we get this form from this form to this form? Okay, we need to think of a way here. So note that we have a power here, right? How do we put the power down? How can we put the power down? So the best way is to use anyone? Anyone?
Sometimes both sides with log.
Okay, so what we need to do is to log both sides. So remember I always preach that whatever you do on your left-hand side, for example, you log base 10, you log your left-hand side, okay, you must also log your right-hand side. So this is what it meant by equal. Alpha x to the beta. Okay, so we log both sides. We log both sides. So now this is still log y, no change. But now we can simplify this one, right? So this is just log alpha plus log x to the power of beta, and we can also simplify this log alpha plus beta log. Sorry, this is not log. This is x. This is x log x. Okay, so now can you see any familiarity with this form here? So we can see that this maps to our y, this map to our a0, because alpha is a constant, right? So log of a constant is again a constant, and this is our x, and this is our a1. This is plus. So now this is a linear version of this equation. Okay, so now what do we need to plot here? What do we need to plot? Are we going to plot x versus y, or log x versus log y? Okay, so this is the issue here. So let's do this. Let me do this. I have the data here. This is my x. Okay, oh, this is 5, and this is my y. My y here is 0 0.5, 0 0.5, 1.7, 8.4, 5.7. Okay, so this is the original data. So let's see how does this plot look like. Okay, so it's not a linear line, right? It's not a linear line. So you can see that it has a curvature here. It has a curvature here. Right, so this is not a straight line. Okay, this is not a straight line. So let's do the log side. So what we want to do is to plot log x versus log y. So let's say this is our log x. This is our log y. And this is just equal to log 10 of this number. And this is equal to log 10 of this number. So we can just do this, and let's plot and see what's the line look like. What's the line look like? So see, now this is a linear line. This is a linear line, right? This is a linear line. So let me change. Let's say now this is the original data. What I'll do is, I don't want to see the line. I just put the line there so you can see that it's not a straight line. It's just a curve. Okay, and again, the same thing here. Okay, let's see, chart type is just this one. Okay, so now we can do the same thing. We can do linear regression on this one, or, okay, I leave it to you how you want to do the linear regression. So let me use Excel here, because we are running out of time. We have only 5 minutes here. So trend line. So this is linear. And what we can see is this. Okay, note that in our case, you can see that there's no error at all. Why? Because this is a made-up data. This is a made-up data, and you can see that it is x minus 0.032. So note now, the one that we get from linear regression is y equal to 1.7517 x. Sorry, let's do it this way. Let's do it according to this equation here. So we know that this is minus 0.3002 and plus 1.7517 x. So this is our equation. So we can see that log alpha is equal to 0.3002 and beta is equal to 1.7517. So what is alpha? What is alpha? 10 to the power of, what is alpha? Can somebody calculate this for me? I'm not familiar using this calculator. Oops. Is it 0.5? 0.5, eh? And beta is that. So now can we solve the equation here? So y, note that y is equal to alpha x to the beta. So y is alpha, which is 0.5, x to the power of beta, which is 1.7517. So this is the equation. And the best thing here is you can also do this on the original curve without having to linearize the equation. So let's do this using Excel and trend line. So, this is not right. Exponential is not correct. Sorry, power. Okay, so power, and let's say display and display. All right, so let's look at the equation here. Let's look at the equation that Excel give you and the one that I calculated just now. Okay, 0.5 x to the power of 1.75. Is it the same as this one? As what we get. So Excel has this capability, so you do not need to linearize. But again, when you use Excel, you do not learn anything, and you do not know how he got or how Excel got this solution. So that is why I'm using all the methods here in the textbook. So this is for your linear regression. So there are equations which is non-linear but can be linearized, and then we can use linear regression to find all the parameters. So in this case, this original equation here, okay, this original data point is this, right? This one. So this is this point, want to click this point here. Okay, so this is this. Okay, we linearize using this plot here. This plot here. Okay, so it gives us the same answer. Okay, so this is your linear regression. For non-linear equation, what we can do, for non-linear equation, we can try to linearize. I think if you read your textbook, page 467, there are some equation that we can linearize. Okay, so I think we are running out of time here. Any question before we go? Okay, I'm going to stop sharing this. I cannot hear you. Can you speak louder, please?
No.
Okay, good. If there's no question, remember I'll give you an assignment later. Okay, I'll give you an assignment. And okay, please, now that you know your scores, your test 1 score, please do something about it. Okay, kalau rasa teruk sangat, either you drop the class or you must work harder for your test 2. Okay, and please remember to form a group of 2 students. I'll assign your project maybe next week. Okay, any questions? Okay, if there's no question, I think we can call it a day. So I think have a nice weekend, everyone. Wishes you a nice weekend. Okay, this weekend I'll be busy. I still have few more papers, about 300 more papers to mark. Okay, so that's it. Until we meet again, thank you very much.
Thank you, Doctor.
Thank you, Doctor.
All right.